Okay, hello everyone, dear students and faculty members. Today we are starting with our new series of Archidesign Timber Talks with the spring semester 2022. And our first guest will be Vadim Siegel, and Demet Hanım will be our moderator. So I want to thank both of you, Demet Hanım and Vadim, for coming and making this happening in here, this Archidesign Timber Talk series. So Demet Hanım, the stage is yours now. Thank you again.
Thank you, Salih Hocam. Good evening, everyone, dear students, dear professors, dear faculty members. Welcome to the first event of Archidesign Timber Talk series for the spring semester. We have a valuable guest, architect Vadim Siegel from Quebec City, Canada. He is partner and senior architect for ABCP Architecture. Thank you, Vadim Siegel, to being with us. It's our pleasure to host you this evening. I would like to introduce him briefly, then I will leave the screen to him. He is partner and senior architect for ABCP Architecture, and he is in charge of many public and private projects of the firm. He has developed a specialization in long span works and has supervised the design of pedestrian bridges, sports center using wood, such as aquatic centers, a velodrome, and a covered outdoor skating rink, which has received international recognition. Vadim Siegel actively takes part in the development and dissemination of wood construction knowledge along with universities or organizations promoting the use of wood. I would like to add a few words. When I visited Montreal and Quebec City in 2016, I visited Secobois, and my colleagues in there organized a timber building tour for me. And I had a chance to see most of the project of ABCP Architecture in Quebec. And I thought our faculty members and students must see the timber buildings, which are explain advantages of designing with timber and how we can use timber as a construction material. Now I am so happy because I have a chance to meeting Vadim Siegel to you as an online platform to share his works and his office works also. This evening we will see various projects designed by ABCP Architecture, and Vadim Siegel will present during this talks the integrated design approach that has made it possible to carry out mass timber long span projects. I will be moderating the section. Please share your question with us at the end of the presentation, and either unmute your microphone and ask directly, or write your questions and comments at chat box. The verse is yours, Vadim. Thank you.
Thank you
Welcome
very
again.
much. Thank you very much, Demet, for the kind word. I will try to share my screen. So let me know if it's okay for you.
Yes, sure.
Yeah. Okay, so let's start. Thank you for the invitation. So thank you to the Faculty of Architecture and Design, and a special thanks to you, Demet, for having me in your timber talk. I'm glad to see that timber construction is well represented in Turkey, and I'm glad to hear that you have the chance to visit some of our works in Quebec. I had the chance to visit Istanbul 16 years ago. I dreamed to be back one day. I hope that the pandemic will give us the opportunity to travel a little bit more in the next few years. So as you said, my specific talk today will be about a long span structure. I will give you some generic information about wood construction in Quebec and in Canada. And I will show you 5 projects that are some examples we have designed in the past few years that show some strategy to have a wood long structure. So let's start. So first, who we are. So we are an architectural firm from Quebec. Quebec is the eastern province of Canada. Our firm was founded in 1987, so 35 years ago. We are around 80 people. So we have architect, technicians, urban planner. We also have some interior designers. And we have people from Canada, but also from France and from South America. So maybe from Turkey one day, we hope so. So we invite you. And we are 8 partners, which each partner has specific skills and some specialization in certain types of project. For myself, I work a lot on some sports centers, but also on some research laboratories, some bridges, some office buildings. But I have a specific interest in wood construction since my studies in France and in Canada. So I had the chance to continue this research in my firm. We work on different kind of project. We work on some schools, for example. We work on some sports center. I will show you some example. This is a research laboratory. This is a wood research laboratory. Some bridges, some soccer stadium. I will show you some example of this kind of project. We also had the chance to work on some factories. And we work on some residential project, not single housing, but multi-housing project, and some office building also. And we have a specific team in our firm who work on urban planning. So it's kind of specialization of a part of our team. So I start with a black slide for dark situation. I think you are all aware about the climate crisis. So Canada aims to set this greenhouse gas emission 30 degrees below their 2005 level. And we have to reach this level in 2030. So it's quite soon. So we have to take some strong action to reach this target. And the building sector in Canada accounts for 38% of all the GHG emissions. So it's a big part of them. And the construction itself accounts for 10% of the global emissions. So it's a lot. So the situation is dark, of course, but as architect, we have the chance and the responsibility to help this situation. Of course, there is an impact of the building operation. So we try to design more efficient building to use less energy. Of course, we have a really cold climate during winter. So heating takes a big part of the energy during winter. So we work on better insulation, some passive passive heating and cooling strategy. But we need also to work on the construction process itself. So we try to use as much as possible local materials. We use, of course, recyclable materials, but renewable materials also, of course. We need to work on the carbon embedded in those materials also, of course. I will share you a small movie, but I just a minute. I will just change something in my share screen because I'm not sure I activate the sound. Okay, it's supposed to work right now. It's just a short film from Greta Thunberg that explains about the importance of the wood.
This is not a drill. My name is Greta Thunberg. We are living in the beginning of a mass extinction. Our climate is breaking down. Children like me are giving up their education to protest. But we can still fix this. You can still fix this. To survive, we need to stop burning fossil fuels. But this alone will not be enough. Lots of solutions are talked about. But what about a solution that is right in front of us? I'll let my friend George explain.
There is a magic machine that sucks carbon out of the air, costs very little, and builds itself. It's called a tree. A tree is an example of a natural climate solution. Mangroves, peat bogs, jungles, marshes, seabeds, kelp forests, swamps, coral reefs, they take carbon out of the air and lock it away. Nature is a tool we can use to repair our broken climate.
Oh, so I hope the sound was good. Sometimes it doesn't work Yeah, it was okay. So I think it's interesting to have this point of view, because steel is a recyclable material. Concrete also, you can recycle concrete, but you will never get once again the material you have extracted from the ground. So what gives you this chance? You can cut a tree, build a house, plant young trees, and build another house 20 years later. So it's quite interesting. And monks, for example, understood that, and they used to plant oak trees around their abbey to be able to build another one in the future. So it's quite interesting to think in this way. Of course, as you probably know, we have a lot of trees in Canada. So Canada is home to 9% of the world forest. But despite this, we don't use as much wood as we should. We use a lot of wood for home since a very long time. But for more, for larger building and construction, it's quite a newer approach to use some wood. But I would say that in the last 15 years, there's really a new way of thinking about wood construction in Canada. So this is a map of Canada in this forest. So it's a really large country. It's more than 5,000 kilometers. So 5,000 kilometers. So we are us in province of Quebec, which is at the east of Canada. But as you can imagine, we don't have the same climate on the eastern part than in the western part. It's really, really colder in Quebec than what we can find in British Columbia, for example. And the trees are not the same at all. And just to show you an example, for example, those are two main trees of the British Columbia. So you have cedar, what we call the Western cedar or British Columbian cedar, which is a redwood. And you have Douglas fir, which is quite a huge tree. And on eastern part of Canada, in Quebec, for example, we have spruce. We use a lot of black spruce for construction. We also have some fir and some pines, but you can see the difference of scale between these two kind of trees. And as example, this is the students there. So this is really giant trees that we don't have the chance to have in Quebec. And as you see in this picture, this is a Douglas fir from British Columbia. It's incredible. It's so nice to see this kind of trees. It's just really huge. And this is black spruce from Quebec. So it's really slim trees, really straight, but really slim. There's not a lot of material in it. So we need to have specific strategy in wood engineering to use this kind of tree. And just to show you a different kind of project we worked on, to just talk about span, because it's the main talk of my presentation. So, for example, we work on some skating rink. So the main span of this kind of building, it's around 30 meters. There is no bleacher there, so it's really short span, but we can have some 40, 50, or 55 meters if you have an indoor skating rink. We work on some soccer stadium, so it's an indoor soccer stadium. So in this case, because of the soccer field, you have to span around 65 to 75 meters span. And we had the chance to work on some bridges where the span can be, really a lot, but we have the chance to work some 90 meters wood span, but we also design a longer steel structure for this kind of building. So the main question is how to build such long spans with such small trees. It's one of our challenge. And of course, this this kind of product you produce in Turkey. That a few minutes ago. So we use, of course, glue laminated timber and cross laminated timber. But as you can see on the left picture, our glue laminated timber is quite different because it's laminated in two directions because of the size of the trees. We have really small pieces of wood that are in the first time laminated in this direction and laminated in the other direction. And most of the glue laminated timber you find in the market are laminated only in one direction. So it's a specific kind of product we find in Quebec. We also wood with the nail laminated timber, so the NLT. It's a quite traditional solution, but it works really well in some project. And we started to have some DLT. It's a double laminated timber. Those are produced in British Columbia, western part of Canada, and it's quite interesting because this is softwood for the main structure, but the double are hardwood pieces, and it's the bind of the softwood is achieved by the moisture exchange between the soft and the hardwood. So there's a bind together. There is no glue in this this product, and in this example, this is a floor or roofing panel. You have acoustic insulation in it, so it's a structural, but it's also an architectural solution. So it's quite interesting. I didn't have the chance yet to use this kind of panel, but maybe soon. So I will start with some project. I will show you 5 projects. I made a selection that we designed in the last few years using wood for long span structure. And what is interesting in this kind of project, and it's what I particularly like, it's the relationship between architecture and structure. In fact, the structure is the architecture and the architecture is the structure. So you need to have a strong relationship between the architect and the engineer to achieve this kind of structure, because is in a standard project, the structure represents about 25% of the budget, and in this kind of projects it's around 40-45%. So it's quite the design of the structure is quite important. So the first project is the Chauveau Soccer Stadium. It's finished in 2009. It was our first large project using wood. As you probably know, in Canada, we are a hockey country. So what we call soccer, what you call probably more football, is quite a new sport in our country. But it started to become more and more popular in the last 15 years. So it's quite interesting. All the kids play soccer. And we have the news yesterday that Canada has been selected for the FIFA World Cup. It's for us, it's a really big news because I think it's the first time in the last 35 years. So we are really proud of that. And so all the city started to add some indoor facilities for the players, and the soccer stadium was designed for the city of Quebec. So it takes place in a large park, which is the Parc Chauveau. But the site is really narrow. We had to integrate this building between a small stream there, and those are power lines, electricity power lines. So it's a narrow, really narrow site for a quite large building. And we have in this project an indoor field, but we also add another one outdoor, and we have some service, some indoor service that are used by the indoor players, but also by the outdoor players. So this is the main entrance floor. We use the slope of the site, sorry, to have the main entrance for the spectators on the upper level of the building. So you have on this level the bleachers. You have a restaurant, restroom, some conference room. And the lower floor, it's for the players. So you have all the changing rooms, you have the access to the field, and you have also the outdoor access to the outdoor field. And of course, on this floor, you have the soccer surface, and it's a full size surface. It's 100 by 60 meters, but it can be divided in 3 small fields for the youngest players. So we have curtains, and it was quite a challenge to have curtains in the shape of the building. But we try to achieve to have these curtains who follow the shape of the roof. So it's quite interesting. But most of the time, the building is used in 3 small fields for the kids. So this is two sections that show the use of the slope of the style, to integrate the building in the site, and it's quite a huge building. So what is interesting that the curve of the roof and the small volume we add in front of the building give the building a more human scale, because it's quite a big one. You have some a closer view of this section. So you have there the soccer field and the changing room there, so which is in the ground or the basement floor, and we had some opening on the first floor to have some lighting in the lower level. And this building has a LEED certification, silver certification. I don't know if you know really well the LEED certification, but it's our environmental certification process. So we need to bring natural lighting in most of the space to be certified. I just want to show you some picture on this first project of the wood the process of the wood construction. So I was in Chibougamau, it's North Quebec, where this kind of structure is built by a company named Nordic. And it's quite interesting to see how the process how to build this kind of project. So this is black spruce tree. The logs are clean of their bark in this machine, and it's bring a rubber strap there and to this scanner. As you can see there's a laser scan there, and the log is scanned in 3 dimensions, and there is a computer who decide itself the optimization of the cut. So you want to cut the piece as to have a lower loss of material. So it's quite interesting, and it can cut with a curve. So it's there's a really strong optimization of the processes. And what is really impressive, it's all this process takes something, I don't know, maybe 1 second or less to scan the log and to cut it. So it's really a quick machine, and it works 24 hours a day, and they stop the machine only to change the blades sometimes. So it's really an impressive process. There you can see one of the arch of the Chauveau Stadium. In this case, it was a partially manual process because of the curve. And as we talked earlier, you can see the glue lamination process in the 2 directions. So you have this 2-direction lamination. And the height of the arch are 1.8 meters, so it's a huge piece of wood. The final shape of the arch is given by a CNC machine. And on this picture, you can see finished arch that are stacked and before shipping. And I like this picture, because it's a kind of involuntary architecture. It's a nice room. Sometimes on the construction site, it's more interesting than the building itself. So some few pictures of the construction. So this is the 2 first arches. Each are, in fact, it's a 3-inch arches, and each half arch have a transportation joist. So these arches are 4 part, but they are double. So there is 8 section of wood to construct to build. Sorry, each arch. There you can see the construction process of the structure. So you can see there's 3 cranes there to lift each half arch. In the other project I will show you later, you will see the process a little bit better. In this case, in this picture, we can clearly see the structural strategy. In this case, we have a 7.3 meters span, and it's 20 meters height in the middle. And the arches, you have the main arches, but you also have the upper structure. This structure allows to reduce snow loads because a flatter roof has less snow accumulation than a sloping roof. So it's quite interesting, but also it gives us the opportunity for the lighting, because in soccer you want to have 45 degrees of the lighting to give a better view on the ball. So by lifting up a little bit the roof, you have a better performance of the indoor lighting. So you have a view of the structure on the other side, and what is interesting is what on this building we had steel decking, but you can really with the perspective you see a lot of wood because of the wood beams. On this picture we can see the longitudinal curve of the roof. So what we want to achieve with that is to integrate the building in its side, but we use an interesting strategy to have the same radius of each arch, because we don't want to have different radius. It will be more difficult to build. So we have the same radius of each arch, but the concrete abutment there are not at the same place. So it's what gives the longitudinal curve of the roof. So some picture of the project the finished project. So we can see there the curve we just talked about, the longitudinal curve, and you can see all the volume we had in the main facade, and this volume are the restaurant, restroom, conference room, some office there. And as I told before, sorry, it's interesting because it gives a more human scale of this building. So this is the main entrance. We had a huge fenestration on this facade to bring some natural lighting in the field. And some night view, which is interesting because we have a better view on the wood structure. We had some lighting to show up this structure. And some inside views of the complex. It's a huge volume for heating also. So we try to bring this volume as low as possible to have less heating energy. And the arch is quite interesting for that, you know, for a soccer stadium, because you don't need to have a ceiling height at the lateral part of the field. You need it in the middle, so the arch is quite interesting for that. And for example, for heating this building, we need 25,000 cubic feet meter of fresh air every minute. So it's a lot of energy. So we're trying to really bring the space and the volume as lower as possible. And this is the view of the lateral space, and you can see the cantilevered structure that cover the public spaces there, and you can see the curve in the foundation in the abutment there, and it's this curve. You know, this arch is installed on the not the same place as this one, so it's what allows us to have the longitudinal curve of the roof. So the second project is the PEPS at Laval University. So it's our main university. It's the only university in Quebec City, but one of our main university in the province of Quebec. And the PEPS is the sports building of the university. So we work on this project since 2009. It was finished in 2013, and there's two different buildings in this project. The first one is another indoor soccer stadium, and the other one is an extension of the existing building where we had a swimming pool, we had an amphitheater, some public spaces, some offices, some changing rooms, and also a public indoor street. I will show you some picture of it in a few minutes. So this is the outdoor stadium, which is an existing soccer stadium. This is the main building existing. So we had this new indoor soccer field there, and it has some spaces for the indoor field, but also for the outdoor stadium. So this is our football, Canadian football field, we have a really strong team at Laval University, so you can have something like 20,000 people there. So we had some spaces there to have VIP boxes and media boxes for the outdoor field. It's a similar organization that Chauveau Soccer Stadium, so I will not go in detail on this plan, but you have a little bit more bleachers in this indoor stadium. It's for university level soccer, so it's a upper level that we can find in Chauveau Stadium, and in the below level, and in the lower level, sorry, you have all the changing rooms and all the storage for the field. This is a cross section of this building. And what is interesting in this building that we use the orientation of the building to give us the opportunity to use a natural ventilation. So the roof acts a little bit like a plane wing, and we have a combined effect of convection of the air and a suction of the air by this wind effect. And we have 150 square meters of opening windows on each facade of the building. It's a computer decision to open or close these windows, and we achieved to lower by 5 degrees the indoor temperatures, because there is of course there is no air conditioning in this kind of building. It will be really it will ask a lot of energy to have air conditioning. So we try to achieve passive cooling, in fact. And you can see there the boxes I talked before, and these boxes are used for the outdoor field. So the boxes again, and the facilities. You have some restroom there that's used by the outdoor spectator also. So it's quite interesting to have those part of the building which is open on the two part, outside and inside of the building. On the left, you have a structural strategy for the arches, but you will see it better in the pictures after that. So this side, the main arches. This is the transportation joint between the two parts of the arch. In this case, the arch are 4 sections. They are not double in the other direction. So you have a transportation joint there, but you have the two half arches that are connected together. It's 3-inch arches once again. So this is the second half arches there. And you can see there with 2 cranes, you have they bring the two half arches together, and you have the same process there, and you have at the end to achieve the connection of the top. So you can have an image there of the size of the structure, and which is interesting in this case, it's the arch is 1.8 meters height in the middle, but there are in this case only 1.2 meters at the bottom. So it gives us a slimmer structure. You know, it's more thin at the connection where they are close to the spectators. So it's quite interesting for that. And in this stadium, we had a little bit different strategy. So you have the 2 layers of wood structure, as we have seen in the Chauveau Soccer Stadium. But in this case, we had steel structure between the 2 wood structures. It's only an architectural choice because we want to express the 2 wood layers. So we decided to have steel structure between the 2 layers of wood. It's more interesting for us. You will see some picture inside. So this is the main entrance of the building. So all this red volume and the black brick volume below are used also for the outdoor bleachers. So this is the VIP boxes, media boxes there, and there you have all the game strategist boxes also, and the lateral facade. And some picture of the inside of the building. So in this case, it's a 68 meters span, and it's a 90 meters height in the middle. This is the restoration sector, and as you can see, if you remember what we have seen in Chauveau Stadium before, the arch are a little bit smaller in this part. And what is interesting also with the steel structure, it's quite slim in this case. So you have all the arch, the spot is on the arch, not on the secondary structure. Also some view of this structure, and there you can see the curtain there, so it's curved because of course we don't want it to be you know, like an horizontal curve, because it's an obstacle for the balls, but in this case it's quite interesting to have this shape. Only few picture of the other building of the PEPS project. So this is the swimming pool. The main structure of the swimming pool is a steel structure, a really basic steel structure, but we have wood decking. And what is interesting in wood decking in a pool, but wood structure, if we had the budget, we will add probably full wood structure. But the wood decking is quite interesting because if you use steel decking, you can have some screws that go through the steel deck, and in the humidity of the moisture, you know, environment of the pool, you can have some rust. So wood is really really performant material for this kind of building. And the pool we have just seen is just there, and the existing building is on the left of the picture. So which is interesting, we had this indoor street, you know, to connect all those spaces together, and it, you know, it allow us to bring natural lighting in the middle of the building also. So this structure is a glue laminated post and beam structure, and the roof is a CLT panel where we had the steel cables below them, and it gives an interesting view on the structure, especially at the end of the day, because this is the west facade. So we have end of the day lighting that adds some shadows effect on the roof. The third project is a skating rink. It's an outdoor ice rink and a small service building. We finished it in 2020. It's in Bois-Châtel near Quebec City. There you can see it's Quebec City just there, and there it's Orléans Island there, and that's St. Lawrence River. So it take place in a future park. We have designed also this park. So this is the main skating rink, but in the future you will have some iced trail there for outdoor skating also in this park. It's a really a simple building. It's so ice skating rink for hockey game. Of course, but also for the families, you know, there's a lot of families in Bois-Châtel, and we had this small building there. It's a really simple building, multifunctional space for a changing room, but also if you want to have some party there or some meetings, and you have a restroom there, and also reception desk there, and this is the garage for the machine who just walk on the ice. There's two types of structure in this building. So we use the mass timber construction for the main roof, and we use light framing for the small building. And it's quite interesting because it will be more difficult to use light framing because of the span, of course, of the main roof, but also for the fire regulation. So we keep the light framing for the small building, and it's a cost-effective solution. So we use two different kind of structure in this case. And the main structure, for the main structure, you have a V-shaped steel structure for the column of the main roof. And what is interesting in this strategy is that you don't need to have bracing spans, because it can be braced all the way long. and we turn this structure at the end to give lateral bracing also. So, and once again, the steel structure, so we have an hybridization of the structure. The steel structure is really slim, so there's a really big contrast between the wood and the steel, which is quite interesting. Some detailing of the structure, and it's really interesting because in Quebec you have a first structural engineer we work with during the designing of the project. And after that, we have the manufacturer as some engineer also, and we have some detailing process at this stage. So some picture of the construction. So this is the foundation. And there you have the steel framing of the small building, and it's quite similar that we do in Quebec for housing, for example. So there is a lot of builder that can achieve this kind of structure. So the construction process of the main roof itself. So you have the steel structure there, and the roof structure. And each truss is divided in two parts. Once again, it's for transportation, so they are bound together on site, and we have the steel cables below to give the resistance of the structure. There you have the wood decking. It's glue laminated wood above this glue laminated hybrid structure. There you have the horizontal bracing of the roof. So above the glue laminated roof, we had plywood panels, and of course roof membraning above. So some pictures of of the project finished. It's really a light structure, so the steel structure is really slim, and to have this flat roof on this really slim structure is quite interesting to see. Once again, you can see the span in this direction. It's around 30 meters span, and we have also some lighting to show up the main structure. And it's used during winter, of course, but it's also used during summer for a deck. Okay, so it's not on ice, but you can also play basketball on this surface. And this is only 2 or 3 pictures of another ice rink we're working on. It's under construction right now. And the main difference is we try to add wood structure in this project specifically, but it's quite the same design. And the two last projects are bridges. And they are really close to each other. I think, Demet, you have seen the Passerelle des Trois Sœurs when you visit Quebec. These two bridges are above St. Charles River in Quebec City. They are pedestrian and bicycle footbridge. It's 2 wood cable structure, but in fact, there are really different kind of structure. The first one was built in 2015. So this is the Passerelle des Trois Sœurs. It spans 55 meters, and it's 4 meters wide. And it's a cable-stayed bridge. So in this case, we have a glue laminated pylon in an A shape. And so this is the main structure. There's no steel in this column. It's fully wood. So once again, it's black spruce wood. And the main pylon is located on the park side of the site. On this part of the site, it's a municipal park, and on the other side, there are some residential project there. So we decided to put this pylon on this part of the bridge to act a little bit like a landmark for the pedestrian. And the stay cable support, I will show you in the next slide, supports steel tubes. And these this steel tube, sorry, support two main glue laminated beams. So you have a top view of the main structure. So the two beam is there, and you have the steel tube there that are supported by the cables. And the bridge decking itself, it's a CLT panel. So you can see the CLT panel there. And what is interesting is the CLT bridge deck exceed the beams to protect them from the rain. You know, so the two beams are really inside of the structure. It's quite important detail to have a long-lasting structure. This is the composition of the decking itself. So you have the CLT panel there. And we had multiple layer of wood structure above the panel for waterproofing. So you have a first layer of wood studs, and after that we had a plywood. So it gives the slope to have for the waterproofing, and after that we had the waterproofing membrane. And at the end, we had the wood decking for the pedestrian. So there is multiple layer, but it's quite important to protect the main structure from the rain. Some picture of the construction process. So the main pylon, which is put in place by two cranes, and you have there the pylon head, and you can see the size of the pylon. It's quite a huge piece of steel. The two main glue lam beam supported by the steel tubes. And there you can see the construction process of a cable stayed structure. So you start from one bank and it's stable, so you can just go further at each time. So it's a quite interesting process. You don't have to go underwater to build this kind of structure. Some picture of the waterproofing strategy. So you can see the slope there and the plywood panels. And on the left picture there you have the waterproofing membrane. And on the right picture, you have the prefabricated decking. And what is interesting in this case on this prefabricated decking is that it's screwed. It screws from below, so you don't have screws on the top of the deck. So once again, if you want to have a lasting system, it's interesting to don't have screws on the top of this kind of structure. And this is the installation of the lateral railing and some finishing, and you have this V shape of the decking, which is interesting for two reasons. Of course, the main structure below is on this side, if you remember. So you don't want to have the longitudinal decking because of for the bicycle, you know, it's not safe. And with this shape also, it cut a little bit the it's not a speed track for the bicycle. So you want to show to the bicycle that it's a shared space with the pedestrian. So some pictures of the project at the end. And it's really interesting. All this park in the 70s, it was only concrete banks. You know, it's a really and in the beginning of 2000, they're starting to add some vegetation around. It's quite interesting park in the middle of the city. And as you can see on this picture, so the wood structure is well protected from the rain. So the main beam is inside of it's below the main wood deck, and the wood deck itself it is exposed below but not on the top. And so the only wood main structure exposed is the pylon, and it's not above the water, so it can be easily treated in the future. So it's once again, it's a strategy to help the project in time. Some pictures of the pylons and the cables. We work a lot with the engineer, of course, in this building to design all the connection. It's quite interesting. They let us to have some specific design for all these pieces. It's important to take in account the view under a bridge. You know, so most of the time you can see from the top, but also from above. And in Quebec, we have a strong winter, so the river is frozen during winter, so you can walk beneath the waves, beneath the bridge. So it's quite interesting to think about the views from below. And I would like to show you also this connection of the main pylon, and we have some detail where the steel plate is integrated in the wood, because we don't want to have rain that came from the top of the pylon that can go between the steel and the wood once again. So you want to have this kind of details. And this is the connection of the main beams, once again protected under the CLT decking. But as you can see, we try to have a ventilation process around the wood most of the time to help the drying of the wood. And this is a winter view, so you can walk on the river during winter. And the last one is another bridge. It's the Tortue footbridge. It was finished last year. It's 80 meters total span from one bank to the other. And we have a pylon there, and it's around 68 meters longest span in this case. It's another cable bridge. Of course, for this kind of span, you need to use cables. But it's not a cable stay bridge. In this case, it's suspended bridge. So we have a V-shaped pylon there that support two main cables, and you have secondary cables that support the bridge decking below. And what is interesting in suspended bridge is that this kind of structure gives you the opportunity to have a really slim bridge decking, because there is no compression in the decking as you can have in a cable stay bridge. So you can have a really slim bridge decking. And it's also easier to add a slope in the bridge decking because you don't have main beams as we have seen in the previous project. And in this case, we raise the main bridge to give room for the lower decking. And it also gives a different view on the middle of the bridge. So this slope gives you the opportunity to have this lower platform there. I will show you in detail after that. But when you are at the top of the bridge, you have a better view on the river. So this is a cross section on the main bridge. So you have the lower decking, the lower deck there, which is a steel structure, and the main deck there, which is CLT panels. And once again, you have steel tubes there that are supported by the secondary cable. You have the same strategy for the bridge decking system. So you had seen before, it's CLT panels and waterproofing system. We also use the same detail, but I wanted to show you the drawing of this detail to avoid water to reach this part of the wood. Some detail of the head of the pylon. In this case, it's interesting because in a suspended bridge, you have less connection at the top of the pylon, so you can have a simpler shape of the head of the pylon. Some conceptual drawings. You can see there the main bridge, of course, but the secondary decking below, and the V-shaped pylons. Another conceptual drawing, and of course, as architect, we want all the slimmest structure, but you know, sometimes we can't achieve a so slim structure, but it's interesting. So you can see there the V-shaped pylon, and the construction process in the building sequences are quite different from the previous project. So in this case, you bring up this pylon, and after that you add the main cable. So once all this is stable, you can add the decking. And this is a view of the CLT prefabricated bridge deck panels. So it's two CLT panels that are fixed together by a steel plate, and you have the prefabricated steel connection to bind each panel together. And so the installation process of the bridge decks. So you have temporary steel cable there just to bring it in place and to give the final shape before adding the final cable. And in this picture, you can see how light this kind of structure can be. So, you know, it's all the main structure is wood. So you have these two big pylon, but this is only 175 millimeter CLT panel, and you can achieve to span such a huge river. So it's quite interesting. This is the installation of the lower deck suspended bridge. So this is a steel structure, but once again, you have the main pylon that support the secondary tube, and the steel structure there is supported on this structure. So it's the wood that supports this this secondary structure. The slope and waterproofing system. Once again, similar to the previous project. So you have the waterproofing membrane, the wood decking, and in this case, the railing installation. And it is a stainless steel mesh we had in this project. And a few pictures of the project finished. We turned the axis of the bridge. It's not the shortest way to connect the two banks, you know, but it connect easier to the streets there. And this is Orléans Island and the Central Lawrence River at the end of the picture. And you can see downtown Quebec City there, and some lighting strategy we used. And there you have the lower deck to allow pedestrians to continue their paths. I have some noise. Their path without crossing the cyclist. And there, yes, you have the lower decking there, and the main bridge above. And which is interesting. Sorry, I want to go back to this picture. Is that the lower bridge gives the opportunity to the pedestrian to continue their path without having a conflict with the bicycle above. So it's interesting in this strategy. So some few picture more of this bridge. And once again, the river is frozen during winter, so it's important to think about the view from below. And there are some people that do cross-country skiing below the main bridge during winter, so you can view this bridge from above, but from below allow. And in this picture, you also see the protected CLT panels and the protection that the main bridge gives to the connection the pylon, so the structure protect itself, in fact. So thank you. This was the last picture. So I hope you enjoy it. And
yeah, thank you very much, Vadim. I think thank you very much for the impressive presentation. I really like this five project. I saw the picture. I have seen this one of the bridge when I visit, but the fifth one, 30-foot bridge, it's really impressive. Thank you very much for your presentation.
Thank you.
I think we have some questions, or I don't know, Salih Hocam, can you see any question? If someone has any question, please.
Yeah, not yet, I guess. We don't have any question on the chat, but if anyone wants to ask something, you can raise your hand and take part. Attendance. We have one hand up. Elif Hocam is.
Yeah.
Maybe I can start to warm up the students. Thank you for the marvelous presentation, Mr. Siegel. So I have one small question, or I don't know, because I want to emphasize it. As an architect, how much are you involved in the solution of the structural details, which makes a huge part of your aesthetical solution? This is my impression. How much time in teamwork or are you spending for the detailing of your ideas?
Yeah, thank you for the question, and it's really interesting question, because specifically in this kind of building, the structure is really important. So you have to be really you need to go really further in detailing, and you really need to have a strong relationship with your structural engineer. And I don't know how it works in Turkey, but in Canada, in fact, in Quebec, most of the time the engineer is hired by the client, and the architect is hired by the client by itself. So it's not, it's a little bit like a blind date. You don't know the engineer you will work with. So you need to have a strong relationship with the engineer. And specifically in this kind of project where the structure is the architecture, you really need to have an engineer that understands that the structure is not only to support a building or to span a bridge, but it's really important in the final aspect of the project. So yes, we spend a lot of time in detailing, and we have two time in the project where we do this detailing in the preliminary process of the design with the main engineer, but after that with the manufacturer of the structure, and specifically with wood structure, the manufacturer have a wood engineer, and we work with them for detailing, because they bring new solutions, and we need to be really involved during the construction process to finish this detailing process. Yeah.
Thank you very much.
I think we have a question. I think Fatma Sıla Turan has a question. I see a question from her side. If she is here, maybe she would like to ask her question directly. Fatma Sıla Turan, can you hear me? Okay. I think I will read her question.
Demet Hocam, Nilay Hocam raised her hand, I think.
Okay. Nilay Hocam, please. Please ask your question, Nilay Hocam. Yeah, Nilay Hocam, we can hear you.
Okay, thank you very much. In fact, I could have waited, but no problem. First of all, thank you very much for this very stimulating presentation. It was really great to see these projects. And with the first year students, especially, we are planning to work with timber also in the second half of the semester. In fact, having seen your projects, I have a few questions. One is about the psychological effect of it, because we are not used to see the use of structural wood in such large span buildings, such as stadiums, swimming pools. I don't know whether it's common or not in Canada, Quebec, but I mean, I think it really helps to bring it to the human scale, especially when we see the interior atmosphere of the buildings. I wonder whether you got such responses from the users of these buildings.
Yeah, it's a really good question, and there is a lot of research right now about biophilia, you know, and the wood is really a strong material for that. And yes, I think, of course, it's difficult to have some, you know, percentage. Do the teams that practice in a wooden building are better than one in a steel building? But I think the atmosphere in the building helps a lot. And in some building there is an acoustic effect also. Some in a soccer stadium it's not really a problem because of the surface of the fields, which is quite a soft surface. Sorry, but for an aquatic center, for example, where the water, you know, all the flooring around the water is really hard surface, the acoustic is a challenge. So the wood help in this case to bring a better acoustic. And yes, it gives an atmosphere that is specific to this kind of buildings. And I'm quite sure that that it helped to have a more calm atmosphere in this building. You can have in a swimming pool or in a soccer stadium tens of people there, kids shouting. So it helps a lot. Yeah.
Mm-hmm. I have another question. Am I allowed to? Demet Hocam. Okay. So in the examples we have seen, in fact, you use timber with steel. I mean, in fact, there are hybrid structural solutions. I would like to ask about challenges. Are there any challenges in use of, you know, those two materials together?
Yeah, that's another good question. Yeah, there are some challenges. In the structure, in fact, the steel is produced by the wood manufacturers. So the challenge is during the design process, because you don't have the wood manufacturer at this stage. So you are the architect and you have the structural engineer. So the structural engineer have to work with this hybrid solution, which is not easy to simulate. But in the second stage of the design, where the manufacturer is in place, and when the wood manufacturer takes in charge the steel structure, it's easier because you need to have the responsibility of the overall structure. And of course, as you can see in some projects, you have steel and wood, but sometimes you have steel, woods and concrete. So it's the whole structure has three materials, and at the end there is an engineer who need to certify that all these materials can work together. So yes, there is some challenge there, but I also think it's the more smart solution, because you use the material for at the place where the strongest. So it's a more creative solution. But yes, you are right. It's a little bit more challenging. Yeah.
Thank you very much. Thank you very much.
Thank you.
I think we have someone who we have a question.
Yes, it's me. Hello.
Hocam, please ask.
Yes. First, thanks for Mr. Siegel for this interesting presentation for me, and I'm sure for all the others. It's fascinating to see how extensive the use of wood as a structure element in some projects, especially for the two bridge where the main pillars is from wood, as I see. But I have one question for the span of the skating project. Mr. Vadim said that this is 30 or 13 meters. I didn't figure out well.
Around 30 meters, yeah.
30.
Mm.
Okay, 30 meters. We see that the structure is supported from both sides, two ends. But in the middle, how it's really supported, as long as the span is amazing, 30 meters from wood. It's so in the middle, how the ceiling is supported, please.
Yeah, maybe I can just bring some pictures.
Please.
It's hybrid structure, so you have steel structure below, and in fact it's the main structure. Yes, I will just share my screen. Can you see it?
Yes.
So you have this steel structure in the middle. So in fact, the height of the trusses there is I will take this one, but the height of the structure there is I don't remember exactly, but it's around probably 2 or 2.5 meters height, and it goes slimmer at the end. But when you see really quickly the structure, what you see is the wood. So it's quite surprising, you know, to see that the structure is higher there and it's slim in the middle. But in fact, it's the steel that permit to achieve that.
Okay. Thanks so much.
Thank you.
We have a question. Enes Yilmaz, our student, asking to you. Firstly, thank you so much. I have a small question. Atmospheric properties such as humidity, temperature, does it have an effect on strength of the timber structure? He asks. Thank you.
If I understand the question, if the moisture has an impact of strength. No, in fact, you know, wood is a living material, so the humidity, the moisture goes up and down. But you, in an indoor building, at one time you will reach some balance in the moisture of the wood, and no, there is no impact in the strength. But you if it's too dry, you can have some small cracks in the wood, and you don't want to be too high for the preservation of the wood also. But for example, I didn't show some aquatic center example, but you know, aquatic center is really a tough climate, you know, because of the moisture, but because of all the product in the air. It's not really a nice air in the aquatic center. So, but the wood performed really well in this kind of, in fact, better than steel. And we have seen some project where we had problem with stainless steel pieces in the aquatic center, but no problem with the wood. So no, I think wood react really well to this kind of an environment.
Thank you, Vadim. Thank you.
Maybe I can continue with the follow-up question, Demet Hocam, if you allow me.
Please.
Actually, I was going to ask, but it has been better after this question about these atmospheric effects and such things. We see that from your 5 examples that you are building with timber structures in Canada, and from your, let's say, projects of your office, we see that you also do structures in other parts of the world. So about the material, timber as a structural material, is it a feasible material as a, let's say, local material, or is it also a useful material to, let's say, to be used in different parts of the world, in different climates, in different geographies? How do you evaluate this in overall?
Sorry, to evaluate, can you repeat the question? To evaluate
the use of timber in different locations of the world, in different geographies. We see examples from Canada where timber is also grown actually with the trees. But what about the other places? Is it still feasible?
Yes, of course. And as you have seen in the presentation, we have a lot of trees, but what is quite strange in some project, and for example, in the ice rink, which is under construction, I showed you some schematic design pictures. the wood are coming from Europe. It's quite surprising, but we don't have any decision in it. You know, it's a tender process, and a wood manufacturer from Europe is cheaper than our wood, so we don't have the choice. But so no, the wood can travel a lot. Of course, it's not for the sustainability. It's not what we want. We want to build with local materials, but we have free markets, so wood can came from Europe, or it can came from western part of Canada. And in fact, western part of Canada is not closer to us than Europe. You know, we are in a really large country. So yes, we can see a lot of wood product in some places where you don't have wood engineered products. So no, it's not. Of course, we tried. Once again, we're trying to use local materials, but we don't always have the chance to do it.
Thank you.
I would like to read a question. Fatma Sıla Turan, one of our students who is attending first class. We see that you use wood in angular forms in most of your projects. Was this a specific choice, or was it because of the structure of the wood to be more sustainable and to reduce material loss? She asks.
In the most angular, you mean?
Yes, they say in angular forms.
Yeah, in the shapes.
Yeah.
Of course, yeah. There's a lot of reason for that. Is in wood you can do it easily. For example, if you want to have a curve and you do it with steel, it's really complicated process. And for example, in the Chauveau Soccer Stadium, we designed the project with wood structure, but our client asked us to compare a steel structure to see if it's more economic. But in fact, if you want to build this kind of arch with steel, it's more expensive because you have to bend huge steel tubes that come from the USA. So it's really complicated. So wood, it's flexible material for this kind of project. It's interesting because you can have a combination of small parts. You can bend it. You can have some curve shape, and for that, it's quite interesting. Yes.
And I have one more question. Again, Samar Bow Hacham is asking, what is the purpose of using wood? It can be effect on the climate with this shape, or just a design?
The reason why you use wood? Yeah, there's multiple reasons. Of course, there is a sustainability reason, of course. There is architectural reason because of the beauty of the materials. It's as simple as that. And sometimes it's for economical reason because as I just said, for some kind of structure, wood can be more economic than other kind of materials. So there's a multiple reason. And in Canada, in Quebec, in fact, we have the government have some program to encourage, the use of wood, and it's quite interesting. So our client asked us to study the opportunity to use as much wood as we can in this project.
Thank you very much, Vadim.
Thank you.
I think there is no question.
Thank you.
Thank you, everybody.
Thank you. Salih Hocam.
So thank you again. Before we finish, I have a small remark. Once more, many thanks, Mr. Siegel, for this very interesting presentation. And it's been our pleasure having you here in our Archidesign Timber Talks. And we have a little tradition here in our faculty for Archidesign Talks. As Bahçeşehir University Faculty of Architecture and Design, we donate to a foundation in our guest's name. So today a donation has been made in your name to the SAY Foundation in Turkey, helping underprivileged children for equality in education. So once more, thank you for all your time and effort. And we hope to see you again sometime, hopefully in person, in our faculty.
Thank you, everybody. It was my pleasure, and you have really nice tradition. It was really nice. Congratulations. See you later, I hope.
See you. Thank you very much for your
Thank you.
presentation. Thank you, Vadim.
Thank you. Bye-bye.
Thank you. See you in Turkey.
Bye, everyone. Bye-bye.
Bye-bye.